Welcome everyone to the maths class. As you know, in the last session, we have completed the vector calculus, and in today's session, we are going to start a new chapter, which is statistics and probability. Okay, let me share my screen. Please confirm if you are able to hear me properly, see my screen, so we can continue. Yes, okay. So statistics and probability, very important topic, not just from the GATE point of view, but from also like general mathematics point of view. It's very important. It will give you idea, like even during your masters also, it will be very helpful in your projects and all. Okay. Overall agenda of this topic is like, first of all, we'll study some basics of statistics, like what is meant by group data, what is mean by ungroup data, and how to find the measures of central tendency and measures of dispersion in case of grouped and ungroup data. Okay, so that is what we'll start with, and then we'll start the probability point, where uh, we will understand different types of events, theorems associated with them, including the Bayes theorem, and lot of variety of problems associated with the probability we'll study there. And after that, we'll study random variable, use of random variables to calculate the probabilities, and the distributions associated with the random variables, such as discrete random variable and discrete random distributions and continuous distributions, okay, associated with the types of random variable, that is discrete random variable and continuous random variable. Okay, and then at the end we'll study the correlation and regression. Okay, so this is overall agenda. Let me write it one by one. So the first point will be statistics, or basics of statistics. Basics of statistics. Okay, in this case we'll study measures of central tendency, and measures of dispersion. Then probability. In probability, we'll study the different types of events and associated theorems with it. Third point is random variables. There are two kinds of random variable. One is discrete, and another one is continuous. Then random distributions, okay. Probability distributions, we can say. Probability distributions. And the last point is correlation regression. Okay, write down. These are the topics which we'll be studying in this chapter. Okay, so with this introduction, let's start with the first chapter, or sorry, first point, which is basics of statistics. Can you like, so whenever we come across some kind of data, okay, the data can be either in the form of group data and or it can be ungrouped data. Okay, grouped or ungrouped. Let me give you one example. So this is a set of marks which let's say 10 students um, or 9 students got out of 50. Okay, suppose in our class total 9 students are there, and the marks of them out of 50 are 25. Okay, so in maths, suppose everyone these are the marks 9 students got. Okay, um, 1 2 3 4 5 6 7 8 9. Okay, this is out of 50. Can you tell me whether this is example of a group data or ungrouped data? Can you tell me, is it an example of group data or ungrouped data? Anyone? It's a random data, right? It's we are not doing some um, grouping here, right? Or let me just give another example. Let's say it's the same if I write 25 to 30, then 31 to 40, and 41 to 50. Okay, so there are 4 students here, there are 2 students here, and there are, let's say, 3 students here. So out of this, um, we are doing grouping in the second example, right, compared to the first case. So this first is like an ungrouped data where we don't have any information, where the data is randomly given. Okay, not properly given like in terms of grouping. Whereas in the second case, we have they already done grouping, so it's called as a group data. Okay, so whenever data is given like this, let's say some range and number of students in that range, or in general some range and frequency associated with that range, then we call it as a group data. And if a random data is given as shown above, we call it as ungrouped data. Is it clear to you all when we say it is grouped and when we say it's an ungrouped? Hello? Is it clear till this? Okay. Okay, now let's start with first point, measures of central tendency. Measures of central tendency. Okay, the first measure of central tendency is mean. What is meant by central tendency? Suppose if you have some data, the central value of that data, okay, can be determined by different ways, either in the form of mean or median or mode. Okay, so these are the three measures of central tendency. I'll repeat: mean, median, and mode. Okay, out of these three, mean is very commonly used and important one. Okay, so in day-to-day life also we use mean. Generally median and mode we don't um, use it as compared to the mean. Okay, so mean or average is like very important measure of central tendency. Okay, mean in case of group data is mean is always represented by x bar. So x bar in case of group data is summation of all the entries, okay, for I is equal to 1 to n divided by number of observations. Okay, suppose we have n number of observations of the data, then sum of all the observations of the data from I is equal to 1 to n divided by n, which is number of observations. Okay, so this is how we'll calculate the mean in case of group data. Sorry, mean in ungroup data. Okay, and like 1, 2, x3 on top data is given. That's how you will solve it. Okay. Suppose if data is given in the form of, let's say, a grouping or something. Okay, so we have some x and the correspondent we have some frequency. Okay, so for example, um, an experiment 100 times, and how many times I'm getting one in let's say when an experiment is like a throwing a dice. Okay, I'll throwing a dice, either I'll get 1, 2, so on 6, right? And you will record the observations. Let's say um, how many times out of 100 you got 1, how many times you got 2. So we got associated frequency to it. Okay, so if this kind of data is there, which is in the form of frequency, then uh, it's like a grouping we are doing, and in such situation the sorry, the x bar in case of group data is equal to summation I is equal to 1 to n fi xi divided by n, fi xi divided by n. Okay, so what is this capital N here, what is this small n here? It is little bit different. Okay, so sum of all the frequencies, okay, is called as capital N. So I'll repeat here, n is small n is the number of observations, x is like a data points, and let's say whenever we have range something like in the previous example I have given, let's say 10 to 20, 20 to 30, so on. In that case, x can be calculated as lower limit plus upper limit divided by 2. Okay, so this is the way you will calculate the uh, x value. Okay, then capital N is the sum of frequencies. Okay, sum of frequencies, and f is nothing but the frequency. Okay, write it down like this. Okay, yeah, just give me a minute. Okay, n is number of observations, x is the data points, capital N is sum of frequencies, um, and f is frequency. So I hope you understood this mean, and so it's a we know how to calculate average or mean. Nothing new into it. Just to give you, just to revise it, I'm giving you these formulas. Another measure of central tendency is median. Okay, if suppose if you have n number of observations, if n is odd, then middle observation itself is median. Okay, if n is odd, then the middle observation itself is median. After arranging the data in, let's say, increasing order or decreasing order. Okay, so either whenever you arrange the data either in increasing order or decreasing order, then middle observation is called as a median if n is odd. If n is even, then average between the middle observations is median. Okay, after arranging the data, in increasing order or decreasing order. Okay, this point is same. So let me give you an example: 25, 26, 29, 30, or 35, 40, 45, 46, something like this. Okay, so how many points are there? 1 2 3 4 5 6 7 and 8. 1 2 3 4 5 6 7 8. Let me give you one more point, that is 59. Okay. So this is odd number of data, right? Nine data points are there, and let's suppose we have already arranged this data here in the ascending order. Then what is the central value here? 2 from this side, 2 from this side, again 2 from this side, 2 from this side. So the central value itself is the middle observation, and we can call it as a median. Okay, but suppose if this observation is not there, 50 for example, then number of data points are even now, that is 3 4 5 6 7 8. Then we got two central observations, okay, or two middle observations, that is 30 and 35. Okay, and then average of it will be equal to 30 plus 35 divided by 2. I hope you are following it. Is it clear, the definition of median? Hello? Hello? Is it clear till this? Yeah, okay. This is in case of ungrouped data. So whatever I have taught you is for ungrouped data. So because the data points are given randomly. In case of group data, things are little different. Median will be equal to L plus n by 2 minus m into C divided by 2. Okay, sorry. L here plus divided by F. Okay, I'll repeat: L plus n by 2 minus m into C divided by F. Okay, this is the formula. What is this L? What is this? What is this M? And let's see it in detail. Okay, suppose group data. Let me give you a simple example: class interval, frequency, and cumulative frequency. Okay, class interval is 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25. Okay, and frequencies, let's say 3, 7, 11, 8, and 2. The cumulative frequency is like 3. 3 plus 7 is 10. 10 plus 11 is 21. 21 plus 8 is 29. And 29 plus 2 is 31. Okay. This is the cumulative frequency. Summation of all frequency, and this cumulative frequency should match here. Okay. The last cumulative frequency and sum of all the frequencies should match. Okay. Coming to the definitions of the L, N, F, etc. L is lower limit of ideal class. Okay. F is the frequency of ideal class. M is M is cumulative frequency above ideal class. Sorry. Above ideal class. Okay. C is the class size, and N is total frequency here. Okay, so let's try to understand these things in the detail. Okay, as data is arranged here like this, the ideal class is the class with the highest frequency, you can say. Okay, so in this case we have highest frequency, right? 11 is with the highest frequency, so you should consider that as an ideal class. Okay, so this is your ideal class. Okay, and now you continue with the or rather than like this. Okay, the best way to calculate the ideal class is just by using formula. Calculate sorry, okay, let me just write down the things here. What is N? Let's start with the simple terms first. N is total frequency. Total frequency is 31 divided by 31, right? Total frequency is 31. So N by 2 means 31 divided by 2. Okay. So L, I'm keeping it as it is now. 31 divided by 2, which is 15.5. Okay. Minus how much? This is the ideal class with the highest frequency. M is the cumulative frequency above ideal class. That is nothing but the 10, right? So this is the M. Cumulative frequency above ideal class in this case is 10, because ideal class frequency, because ideal class is just below it. Okay, is 10. Okay, into C. C is a class size. Class size is 5, because 0 to 5, 5 to 10, we have difference of 5 there. So class size is 5. So I hope you got N, M, C. Now next one is F. F is what? Frequency of an ideal class, that is 11. Okay. And what is L? L is the lower limit of the ideal class. That is, limit is 10 to 15. So limit of ideal class is 10. Is it clear till this? How I have calculated all the terms? And if you further solve it, you should get an answer around, let's say, 12.5.
That is 31 by 5.
Sorry, 31 by 2. Thank you. N by 2. N is 31 divided by 2. Yeah, thank you. I'll repeat. 10 plus 31 divided by 2 minus 5. So minus 10 multiplied by 5 divided by 11. Okay. So this is like 15.5 minus 10, which is again 5.5. So this is 5.5 into 5. Okay, so this is 5.5. You will get 5.5 into 5 divided by 11, and then add it to the 10. Okay. Yeah, this is how you will calculate the median. If you look at the previous exams, they are not asking much questions on this mean, median, and mode. But these things are very important to know before we jump into the more details of correlation regression or probability distributions, etc. Okay, so you should have some basic knowledge first. What is meant by mean, median, and mode. Then only we can jump to the actual uh, topics which are very important from the exam point of view. Okay. So the next point is mode. Write down heading mode. Mode is very simple. Most frequently repeated observation is called as a mode. Okay? Whenever you got some data points, okay, the most frequently repeated observation is called as a mode. Observation is called as mode. Okay, so let's take an ungrouped data. 1, 2, 3, 4, 5, 2, 3, 11, 14, 2, 3, 21, 2, 16, 21, 3, and 19. Okay, or let's say just 19. In this case, which observation is repeating frequently? Two is repeating, right? Two once, twice, thrice, and 4 times. Is there any other observation which is repeating these many times? No, right? So mode of this data is 2 because 2 is repeating 1, 2, 3, and 4 times. How many times 3 is repeating? 1, 2, and only 3. Okay, so that's why in this case I'll not write 3 as a mode. But for example, if I have 3 also in the observation, then 3 is also repeating 4 times and 2 is also repeating 4 times. In that case, the data will have two different modes, that is 2 and 3. So we have to call it as a bimodal data. Okay, so that is the main reason, like in some situations we cannot achieve better central tendency in case of mode, even if in mean, like for example, if even if in median, for example, if in our class, for example, 10 students are there, 8 students scored like very good marks out of 50, like in the range of 40 to 50, and 2 students, let's say, has casually given the paper and did like very worst, like 0 to 10 marks. In that case, like achieving the central tendency by means of mode or let's say median will not be like effective, you can say, or will not give clear idea about the situation. Okay, this is just one example. There can be many such situations where mode, let's say mode can be more than one, and ultimately judging the central tendency in that situation becomes difficult. So that's why out of all these central tendencies, like a mean, median, and mode, mean is most commonly used. Okay, coming towards the group data, mode is calculated as mean minus 2 times mean, or you can also calculate it as L plus delta 1 divide delta 1 plus delta 2 into C. Okay, so here uh, what is this delta 1, delta 2 and L? Let's see. Okay, let me give you a simple example first. Let's say if we have interval and frequency 0 to 10, 10 to 20, 20 to 30, 30 to 40. Okay, and so on data points are there. For example, okay, let me write it itself. 40 to 50 and 50 to 60. 11, 14, 17, 8, 5 and 3. So out of this, highest frequency is here. So in this case, we call it as a mode class. Okay, in this case, we call it as a mode class because their highest frequencies there. We know the name itself indicate here. Most frequently repeated observation is mode. So in case of group data, there is no single observation. There is a data is given in the form of a group, right? So I am saying it as a group data, and so in that case, we will not have a single mode. So we'll have a modal class there, which is in the range of 20 to 30. So what is L here? L is as I said, lower limit of the class, that is 20, plus what is delta 1? Delta 1 is a difference. I'll write here delta 1 is a difference between modal class frequency minus the frequency above the modal class. Okay, these two, 17 minus 14, that is 3. And delta 2 is the difference between modal class and the next frequency. So 17 minus 8, which is 9. Okay, so this is your delta 1 and this is your delta 2. Okay, delta 1 is how much? 3 divided by 3 plus 9 into C is what? Class interval, again, that is 10. Okay, so the only two new terms, that is delta 1 and delta 2. L is same as before, C is same as before. Okay, you solve it, ultimately you will get some answer, 22.5. Okay, I hope you understood the overall process and the terminologies, that is basics of statistics, that is mean, median and mode. Okay, in case of both grouped and ungrouped data. Okay, so what we have understood till now is just the measures of central tendency. Okay, what is the measures of central meaning is we are trying to find the central value of the given data. But sometimes data is like dispersed. Okay, it can be like dispersed very random, like diversely, or dispersed in a narrow range. Okay, if data is dispersed in the narrow range, then like we will say that it's like a good observations we have, and the data collected by an instrument is like we can say a good instrument with accuracy. But let's say if data is like a very dispersed, like the range of data, or let's say the data points are very far from each other, uh, then we'll obviously have a very less kind of let's say trust on the measurement of that data, right? So for example, let's take a simple example. um, mm, okay, let's take an example. If we have 10 weighing machines, okay, and you are performing, or you are trying to take your weight, okay, trying to get your weight on all these 10 different weighing machines. And suppose, for example, let's say in these 10 machines you got your weight in the range of, let's say, 70 to 71, for example. Okay, So in some case you got 70, in some case you got 71, in some case 70.5, 70.2, 70.8, so on. But overall, if you see, like, the range is not that high. It's just a 1 kg difference, and that too with the 10 machines. Okay, so at least you will get a rough idea that maybe your um, weight is within the range of 70 to 71. So you may judge it like a 70.5, for example. Okay, and you will be basically like, you can trust that. Suppose if I say your weight is 70.5, you will trust me, because all these 10 machines has given you, let's say, uh, the weight in the form of 70 to 71. An average we have calculated as 70.5. So you will trust that average, right? You'll say that I can trust this average, because um, the dispersed point, 10 different points, were not like tremendously away from each other. But suppose if I do some wrong settings in the weighing machines, and next day you come and take your weight, and the weight is in the range of 60 to 80 now. Okay, and let's say if I calculate average and say your weight is 70.5. Okay, your weight is remaining, say, average mean is same now, but the dispersion is quite high now. Some machines are giving you data in the range of, let's say, 60, 65. Some are giving you in the range of 80, 85, something like that. But ultimately, while calculating the average or mean, you are getting 70.5, same value as that before. But in the second case, obviously you will not be confident enough, right, that my weight is like 70.5 or not, because the actual data which is which you are seeing is like uh, tremendously dispersed, yeah, and that's not the good scale, or let's say good dispersion in the range of, let's say, 60 to 80 for a weight quantity like this. Okay, so you will say that you will not trust these observations or the machines. So not only the mean, but also the dispersion of data is also equally important, right? Mean is giving you the idea about the central value, that's fine, mean, median, and mode. But that is not just sufficient. How data points are dispersed, that is also equally important. Okay, so the next point which we are going to study is the measures of dispersion. Write down heading: measures of dispersion. Okay, how data is dispersed can be calculated either in the form of range. So the example which I have given you in the form of weight, let's say 70 to 71, that was the range, right? Or 60 to 80, that was also the range. Okay, so if range is large, data is like widely dispersed. If range is small, then you can say like data points are very close to each other, so um, you can trust it. So another is variance. Variance or a standard deviation. Okay. The next one is ANC. Okay, variance, standard deviation. Then what else we have? Yeah, mean deviation, quantile deviation, etc. Mean deviation, quantile deviation, etc. So you might have heard out of all this, but mainly, like most of the cases, you might have heard only one parameter, that is standard deviation or variance. Okay, standard deviation and variance more or less same thing. I'll explain you what is the difference between them. But the main, you can say, the major or the best measure of dispersion is like a standard deviation. Okay, so let's start with them one by one. What is range? Range, as I said, it's like a max value to min value or min value to the max value, right? Min value to max value. Okay, we know, let's say data is in the range of 10 to 100 or 50 to 55. So depending on the range, you will say like how data is dispersed, right? Okay, the most important measure of dispersion is standard deviation. So write down heading standard deviation. You can say it as SD or you can say it as sigma also. Okay, and sigma, and that is nothing but the under root of variance. Okay, and the root of variance is nothing but the standard deviation. Okay, so first of all you have to calculate the variance, and then only you should calculate the standard deviation. Okay, what is variance? Variance is equal to summation I is equal to 1 to n xi minus x bar whole square divided by n. Okay, or you can also write it as 1 upon n summation I is equal to 1 to n xi square minus x bar whole square. Okay, both the formulas are valid. Okay, so this is xi, so this is one bracket and this is another bracket. Okay, summation of xi square divided by n minus x bar square, either that formula you can use or summation 1 upon n, sorry, 1 upon n summation I is equal to 1 to n xi minus x bar whole square. Okay, I will not go into the derivation part of it, how this is derived from it. You can just simplify and solve, you will get this answer. Okay, if you just simplify this, a minus b whole square, that is a square plus b square minus 2ab, you will get that. Okay, so we have two formulas. Whichever formula you find easy, you use it. Okay, so variance is important to calculate the standard deviation. So if variance of data is less, what is the meaning of it? Variance is less means the consistencies of data is good, right? Good consistency, or consistency is high. Okay, and you can clearly see xi minus x bar whole square is there, so variance will never be negative. Okay, and variance of a constant in observation will be zero, right? If observations are constant, then its variance is zero. So for example, if you are doing your checking your weight in 10 different machine, and in 10 different machines you got same weight, let's say 70.5, 70.5, 70.5, so on. So your mean is 70.5, but your variance will be zero because all the observations are constant, they are not dispersed at all, right? So variance in case of constant observation is zero, so VC is equal to zero. And summation of I is equal to 1 to n xi minus x bar is zero. Obviously that should be zero. Okay, because it's a difference between the mean and each individual you can say observation. So some observations will be below mean, some observations will be above mean. So ultimately you will get some positive differences, some negative differences, and after adding them you will get zero value. So that's why in order to calculate the variance, we are doing square of it, xi minus x bar whole square. Okay, Look at the formula, xi minus x bar whole square we are writing. Okay, and then we are adding it. So if you don't square it, what will happen? If you don't square it, ultimately you will get 0, because summation of all the interval, if you subtract it from if you subtract the in mean from each observation, and if then you add it, you will ultimately get 0 value, right? So that is what I am trying to explain. This is the reason we are squaring it. But if you square it, we are actually like um, not getting exact dispersion. So that's why we are saying a standard deviation is under root of the variance. Okay, so again we are taking a root of it to get the standard deviation. I hope you understood the overall process to calculate the standard deviation and variance. Is it clear till this? Any doubt in the standard deviation and variance formulation? Okay, so whatever the formulation I have given is in case of ungrouped data. Okay, this is in case of ungrouped data. The formulation in case of group data is a bit different. Okay, so let me just rub this part and I'll give you here itself. Okay, in case of group data, variance is equal to sigma x square, which is 1 upon n, summation fi xi square minus 1 upon n, summation of fi xi whole square. Or another formula is 1 upon n, summation of fi into xi minus x bar whole square. Okay, so whichever formula you feel easy, you can use it. One more relationship, 6 times quantile deviation is equal to 5 times mean deviation is equal to 4 times standard deviation. Okay, so from this you can say quantile deviation is equal to 2 by 3 times standard deviation. Okay, and mean deviation is 4 by 5 times standard deviation. Okay, so these are the formulation you should know. Range, what is meant by range, what is meant by mean, what is meant by variance, quantile deviation, and mean deviation. So there is no need to uh, separately calculate mean and quantile. We already have some relationship with the standard deviation, and this is how we can get it. So the most important one here you should know is standard deviation. Okay, how to find the standard deviation in case of grouped and ungrouped data. Okay, one more point is skewness. Okay, skewness. Okay, measure of lack of symmetry is called as skewness. Measure of lack of symmetry is called as skewness, and skewness is calculated by the formula skp, that is Pearson's coefficient of skewness. Okay, skp means Pearson's coefficient of skewness. Pearson's coefficient mean minus mode divided by standard deviation. Okay. Mean minus mode divided by standard deviation sigma. Okay. So if your mean is here and sorry, if your mean, median and mode is same, mean is equal to mode is equal to median, in that case the or okay, here itself I have written, if mean is equal to the median is equal to mode, then the distribution is like properly symmetric across mean value or median value or mode value. And in that situation, we can say that distribution is symmetric. It's not skewed towards left hand side or right hand side. Okay, or let's say positively or negatively skewed. But if you look at the first question where mean is smaller than median is smaller than mode. Okay, mode is higher than median, median is higher than mean. In this situation, data is negatively skewed, you can say, and you can also call it as a left skew. Yes, in the similar way, if mode is less than median is less than mean, in that situation this is positively skewed data, and you can also call it as a right skew data. Okay, so if your mean, median and mode are not lying on the same uh, point, in that situation the data is like not dispersed correctly, or not symmetric distributed. The distribution is either positively skewed or the negatively skewed. Okay, and this is how you will calculate the skewness. The last point before we jump into the let's say is coefficient of variation. Coefficient of variation is standard deviation divided by mean into 100. Okay. Standard deviation and coefficient of variation are the better measures for identifying the consistency of the data. Okay, so write down sentence. Standard deviation and this coefficient of variation, these are the better measurements of identifying the consistency of the data. Okay, let's take one question and then we'll move towards the probability topic. Find mean and variance of first n natural numbers. N natural numbers means 1, 2, 3, so on till n. Okay. Calculate mean and variance. Solve it and tell me the answer. What does mean? Very simple question. Sum of n terms divided by n, right? This is how you calculate mean. Sum of n natural numbers is n into n plus 1 divided by 2, right? And divided by n is also there, so n will get cancelled. So n plus 1 divided by 2 will be the mean of n natural numbers. Do you agree? Hello? Is it correct or not? Yes. So can you find the standard deviation or variance? Yeah, in this case, variance they are asking. Can you calculate the variance? What is the formula for the variance? Sigma x square is equal to 1 upon n summation of xi square minus x bar square. So 1 upon n, 1 square plus 2 square plus so on till n square, right? Minus n plus 1 divided by 2 whole square. And what is the squares of n natural number? That is n into n plus 1, n into n plus 1 into 2n plus 1 divided by 6. N will get cancelled. Okay, divided by n was there. N plus 1 divided by 2 whole square. N plus 1 divided by 2. If you take common, 2n plus 1 divided by 3 minus n plus 1 divided by 2. If you solve it, ultimately, finally, you will get the answer n square minus 1 divided by 12. Okay. So it's very important. Write down this formulas. Mean of n natural numbers is n plus 1 divided by 2. And the variance of n natural numbers is n square minus 1 divided by 12. Okay. So I hope the basic statistics part is clear to you. You understood what are the measures of central tendency and measures of dispersions in detail. So now we will start the probability topic, and later we'll again come back to the statistics part when we study the distributions and the correlation and regression. But to study distributions and all, we have to first understand the basic probability. Okay, so now we'll start the probability topic, understand the basics, theorems, and solve some questions on it. Okay, and in upcoming sessions we'll study the random variables, distributions, and all. So let's write down heading probability. Write down heading probability. Couple of slides I have made ready just to save some time. What is meant by random experiment? So write down these definitions. What is meant by random experiment? Whenever the outcome of an experiment is unpredictable. Okay, so we cannot say that outcome will be like surely you cannot predict basically the outcome. Okay, so if you throw a die, we cannot surely say I'll get 1 or 2 or 3 or 4 or 5 or 6. You can get anything out of 1 to 6. Okay, so surety is not there. Okay, so it's unpredictable outcomes you can get, and that's why if that is the case, then that kind of experiment is called as a random experiment. Okay, then that kind of experiment is called as a random experiment. What is sample space? Sample space is collection of all possible outcomes of an experiment. Okay, so 1, 2, 3, 4, 5, 6 are the outcomes of the uh, experiment when you toss a, let's say, a die. Okay, or when you throw a die, either you get 1, 2, 3, 4, 5, 6, right? So these are the possible outcomes of an experiment. Sample space. So that is nothing but a sample space of the when you throw a dice. Similarly, when you toss a coin, either you'll get head or tail. So the sample space is head comma tail. That's all. Okay. So this is how you will write down the sample space. So it's a collection of the possible outcomes of an experiment. What is event? Event is an outcome of an experiment. Okay. Suppose if you are tossing a coin, you are getting head, then you will say occurrence of head is an event for this experiment. Suppose if you are throwing a die and you got 4, then 4 is will be the outcome of the experiment, or that is a event, you can say. And probability will be the number of favorable cases divided by a number of possible cases. So what is the probability of getting 4 when you throw a dice is like probability of that event of getting 4, which is uh, number of favorable cases will be single, so 1, and number of possible cases, that is total number of cases, that is 6. So 1 by 6 will be the probability, right? So this is the definition of the probability, number of favorable cases divided by sample space or total number of cases. Okay. When probability is equal to 1, it means that is sure event. Okay. Probability of sure event will be 1. Okay. If probability is 0, it means that is an impossible event. Probability is 0 means that is impossible event. So whenever you toss a coin, either you'll get head or tail. There is nothing. Let's say you cannot expect um, uh, the the coin will show something some other than head and tail, right? Like 1, 2, or 3, some number. That is impossible event, right? So in such situation, that probability is 0. So what is sure event? Sure event means probability is equal to 1. And what is impossible event? It means the probability of that event is 0. Sure event is 1. Impossible event probability is 0. Clear? Okay. Write down. And then we'll go to the next slide. Okay. Write down. Next heading, type of events. Write down heading, type of events. Type of events. So first one is dependent, independent, and mutually exclusive. What is meant by dependent events?
Screen coming, sir, in front of the page.
Okay, just give me a minute. So are you not able to see my screen?
Now it is okay, sir.
Yeah, okay. Um, yeah, so the dependent event is like a dependent, independent, or mutually exclusive. When we say events are dependent, whenever we have some when one event is dependent on other, okay, or when we have outcome of experiment, some common outcome of experiments in two events, right? So for example, in this figure, first figure, we have let's say event A and B. Events are generally shown like circles in a Venn diagram. This is the Venn diagram. Sample space is shown by a rectangular box, and in that you will draw the events. So if you have an intersection in between two events, okay, then these two events are called as a dependent event. Okay, so outcome of an experiment depends on the outcome of another, then you call it as a dependent event. Okay, what is meant by mutually exclusive? The situation when two events cannot occur at the same time. Okay, so independent two events A and B can occur at the same time. Okay, so for example, what what is the probability of getting a even number and a prime number when you throw a dice? Okay, so 2 is a prime number, right? And 2 is also an even number. So one event is a prime number, another event is a even number. So there can be a possible outcomes which satisfies both the conditions, right? So two events can occur at the same time. So that's why we said it's as a dependent. But when two events cannot occur at the same time, okay, then you call it as a mutually exclusive. In the same sample space, if two events cannot occur at the same time, then you call it as a mutually exclusive. So what is the probability of getting even number and odd number? So it's not possible that number is even at as well as odd. Okay, what is the probability that the outcome of a dice is even as well as odd? That is not possible, right? Either you'll get even or odd number when you toss a die. So there is no, let's say, a situation when two events occur at a time. Either it will be even or it will be odd. Is it clear till dependent and mutually exclusive? Hello, are you are you getting it when you say it as a dependent events and when you say it as mutually exclusive? Okay, if I assume you understood it. um, Whereas in case of independent events, okay, in case of independent events, one event remains unaffected by the occurrence of the other event because its sample space itself is different. Okay, suppose if we have two dice, from one die, if I'm taking a card, let's say that is black card, what is the probability of getting a black card in the second dice? That is independent, right? Because the second dice is like is a different, completely different new sample space. So basically, when one event remains unaffected by the occurrence of the another event, then in that case we call it as a independent events. I hope things are clear till this. If you have any doubt, feel free to ask. Is it clear? Can we proceed to the properties? Hello? Yeah, okay. Let's study some results. Okay.
That one is A intersection B is equal to 0, is it, sir?
Yes, we don't have an intersection even in mutually exclusive as well as independent, right?
Yeah. That is 0, no? A intersection B is equal to 0.
0, yes. Okay. Write down there's some standard results. Okay. Write down the standard results. First one is a complement theorem. Probability of E complement is 1 minus probability of E.
Green is not updated.
No? How about others? Okay, just give me a minute. Just a minute. Yeah, I hope now it should be. Write down. Probability of A complement is 1 minus probability of A. Probability of A will be 1 minus probability of A complement. So this is the complement theorem. Complement means A complement means probability of not occurrence of A. That will be 1 minus probability of occurrence of A. Right? So that's what I have written here. Addition theorem. So whenever two events which are dependent, then probability of A union B, okay, A union B is like union means what? Union means saying probability of A or B, right? A or B. Union means or, okay. Or means you are reducing the constraint. You're not putting more and more constraint. Whenever you say and, you want this and that, means you are putting more and more constraints, right? So you want even number and you want a prime number. So you are saying that you are putting more and more constraints, right? So whenever you say either even number or let's say a prime number, it means you are reducing the constraint or increasing the possibilities, in other words. Okay. So probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. See, whenever you are considering probability of A and probability of B, this intersection part you are considering two times. That's why you are subtracting it one more time. Okay, one time, so that you will be able to cover that area only once. I hope you understood the formula here. But whenever you have two mutually exclusive events, then intersection is not there. So in that case, probability of A union B is equal to probability of A plus probability of B. Okay. And probability A plus probability of B will be probability of A plus probability of B. So either you can union or positive, or you can say you can use word or for it. Clear? Clear till this? Okay. So the next theorem is so for example, I'll give one simple question on this. Probability of die showing a number 3 or number 5 is probability of 3 or 5. That is probability of 3 plus probability of 5. 1 by 6 plus 1 by 6, 1 by 3. Okay. So in such kind of situation, you can use the addition theorem. Okay. So because these two terms, getting 3 or getting 5 is mutually exclusive. They are not depend on each other, or let's say occur at a time. You cannot get 3 and 5 at a time when you throw a single die, right? So that is the reason they are mutually exclusive. So so if their intersection is 0, and probability of A union B will be probability of A plus probability of B. Okay, so 1 by 6 plus 1 by 3, that is equal 1 by 6 plus 1 by 6, that is 1 by 3 is the final answer. Okay, the next theorem is multiplication theorem. In this theorem, whenever two events A and B are the dependent events, okay, means occurrence of one event depend on the occurrence of other two. In that case, probability of A intersection B is probability of A into probability of B when A is already occurred. Okay, let me use the highlighter here, or yeah, so probability of A into probability of B when A is already occurred. So probability of B slash A, meaning of it is probability of B when A is already occurred. Okay, that is a conditional probability, right? We are using a condition that probability of B given that A event is already occurred. Okay, in the similar way, probability of A intersection B can also be written as probability of B plus, sorry, probability of B into probability of A when B is already occurred. Okay, probability of B when B into probability of A when B is already occurred. So like that you can write it. Okay. Next is same way when we have three events. Probability of A intersection B intersection C. Probability of A into probability of B when A is already occurred into probability of C when A and B is already occurred. Okay. So these two are again conditional probabilities.
Sir, here why intersection comes up? P of A intersection B, why we are writing?
We want a situation like we want to calculate, let's say, this probability. Whenever you want to calculate this probability, that probability of getting let's say a prime number as well as a even number. Okay, in that case means what is the outcome of that event? It will be prime as well as even, right? So it means two events are occurring at at the same time. So that is the situation. So this is a simple example. I'll give you some questions so things will be clear there. So whenever in such kind of situations occur, whenever the two events are possible occurring at a time and you want to find the probability of it, that is the case where you need to calculate the probability of A intersection B. Okay, if events are dependent, probability of A into probability of B when A is already occurred, this is how you will calculate. Intersection means and, okay, you are applying more and more constraint. Okay, and basically you will multiply here. Okay, so whenever you multiply two different probabilities means two different numbers which are less than one, your final probability will become smaller. So basically you are increasing more and more constraint and reducing the possibilities. Okay, so that's why intersection means and in mathematical terms it is multiplication. Okay, so that's why we are multiplying these probabilities, right? You can see these red dots which I am drawing. Probability of A into probability of B when A is already occurred, so on. But if events are independent, okay, so that occurrence of B doesn't depend on the occurrence of A, okay, or the occurrence of A does not depend on the occurrence of B, means this conditional probability is not there. Okay, in such situation the formulation becomes quite easy. Let me go to the next slide, and this is what you can say in case of independent event, that is probability of B intersection A or A intersection B, or in other words probability of A and B is equal to probability of A into probability of B. Okay, I hope you understood the difference between dependent versus independent. Let me give you one simple example to make the things more clear. Okay, suppose in this bag 10 marbles are there. Out of these 10 marbles, 2 are black, 4 are red, and 4 are green. So when you put, so my question is, what is the probability of getting a black marble? Okay, um, 2 times. Okay, what is the probability of getting marble, black marble, when you take 2 marbles out of that bag? Okay, one after the other. In first situation, you are putting the first marble back into the box or that bag. So total 2 black marbles are there. So probability of getting a black marble when you take a first marble will be 2 by 10. And then you will again put that into the uh, bag. Then it will be like a new sample space again, and then probability of getting a black marble will be again 2 by 10, right? So it's a 2 by 10 into 2 by 10 is 1 by 25. So here it's a probability of A and it's into probability of B, right? Because here what is happening is we are creating an independent event, because we are creating a new sample space again by putting the first marble back into the bag. But in second situation, if you see, we don't put the first marble back. So what will happen? Probability of first probability getting a black marble at the beginning will be 2 by 10. Okay, but if you are not putting that marble back into the bag, you will get 1 marble out of 9. So that is the new probability. So this will be a probability of B when A is already occurred. What is A? You have already taken a black marble. Okay, so that's why in this case this is a conditional probability, because the event is, the occurrence of event B is now dependent on the occurrence of event A, and that's why in this case you will get like a little less probability now, 1 by 45. Okay, I hope you are getting. So this is an example of independent events, and this is a dependent event. And I hope now you understood why intersection is needed in probability. Is it clear now? This is intersection itself. Probability of A intersection B is equal to probability of A into probability of B when A is already occurred, and in this case it is probability of A into probability of B. That's all. Is it clear till this? Any doubt? Hello, is it clear? Yes, okay. So let me go to the next slide, and one more question. I have already solved you. I'll explain that to you. Just go through it. Mm. Which is in the same term, like why intersection is important. Okay. Suppose 5 black, 7 red, and 6 green balls are there in a box, and they are drawn at a random, one after the another, without replacement. Okay, without replacement, they have clearly mentioned. Means you are, whenever you are taking first ball out, don't put back into the box. Okay, find the probability that all the balls are black. So it is like a finding. So the first case is all black. All black means probability of getting a black ball into probability getting second black ball, given that first is the black. into probability of getting third black ball given first and second is black ball. Okay, so out of 5 you are taking 1, so it will be 5 by 18 is the probability for getting a first black ball. But out, so we have already taken 1 black, so now next time we have only 4 black balls, so the next probability will be 4 by 17 because 18 will become 17 now because 1 ball is already taken out and that is black ball. And now the next time the probability of getting a black ball will be 3 by 16. Okay, so here if we are performing an experiment without replacement, that becomes an dependent event, and that's why you can see conditional probabilities in the formula. That is probability of b2 when b1 is already occurred, probability of b3 when b1 and b2 is already occurred. Okay, I hope it's clear. The next one is of different colors. Of different colors means either you will get black, no, you have to get 1 black, 1 red and 1 green. The probability of getting a black ball is 5 by 18. Let's say first time you are getting a black ball, 5 by 18. Second time, let's say you are getting a red ball, that is 7 by 17. And the third time you are getting, let's say, a green ball, so that is 6 by 16. So you can interchange the sequence also. First red, then black, and then green, or first green, then black or red. Ultimately, you are getting 5 multiplied by 7 multiplied by 6 in the numerator, and in denominator you will get 18 multiplied by 17 multiplied by 16. That's all. So this is the probability. So probability of, and the next one is 2 black and 1 green. Here 5 by 18 multiplied by 4 by 17 into 6 by 16. Why? Because we have 6 green balls and only 16 balls are left, so 6 by 16 is the probability. Okay, so this is the way you can use the multiplication theorem, or you can say intersection. Okay, and means multiplication means intersection, or means union means addition. Okay, I hope it's clear. So as I said, we have studied addition theory and multiplication theory, right? Addition theory will be helpful whenever we have to find the probabilities, such as, let's say, what is the probability of getting at least 3 or at least at most 3. Okay, when you when you throw a dice, what is the probability of getting at least 3 or at most 3? So this kind of examples, whenever the term and or is used, it's a and means so let me draw an horizontal line here. And means intersection, or means union. Whenever you when you will use a multiplication theory you will use whenever the terms such as simultaneously, one after the other, one by one, as well as successively, and is used. So these kind of situations are there, then you will go for the multiplication theory. I don't think you have to remember this. Naturally it will come out when you think on it. Okay, so but this is just for your information that in which situations this multiplication theory and addition theory is important. Okay, so basically under which situation you will calculate union and under which situation you calculate intersection should be clear to you. Okay, next point. So till now I have explained you is like whenever you have an independent events, the probability of A intersection B will be probability of A into probability of B. And if 3 events are there, then probability of A intersection B intersection C is probability of A into probability of B into probability of C if events are independent. Why? because in that situation, this probability of B when A is already occur is probability of B itself, because it's an independent event. Okay, and the probability of A when B is already occurred is probability of A. That's why we are directly writing these probabilities. Okay, I hope you are getting it. So before we jump into some more questions, I would like to uh, go through some of the some more formulas. Okay, suppose you come across a situation where you have a sample space, where you have let's say two events which are occurring, and you just want to find the probability of only A. I am saying you don't want to get this another part including the intersection. Try to understand. Okay, so it means, let's say event A is uh, a prime number and event B is um, even number. So what is probability of getting a prime number but not an even number? I hope you are getting what I'm saying. Okay, probability of getting a prime number, okay, and not a even number. B complement means not an even, not a even number. Okay, so in such situation, what you need is you have to take a probability of A and just subtract the intersection part, right? If you subtract the intersection part from the probability of A, you will end up with the probability of only A. Okay, means probability of getting a prime number only. I hope you are getting it. We are, by doing this, we are just able to calculate the area which is shaded in this green color. Okay, so it's like an apple symbol where some part of the apple is cut. Okay, so we are not considering that intersection. I'm repeating again and again. From the probability of A, we are subtracting the probability of A intersection B, so we'll get probability of only A. Okay, clear? The next one is probability of only B. In the same way, probability of only B will be probability of B minus probability of B A intersection B. So it's a probability of B and not A, basically. Probability of B and not A. So that's why A complement is written here. Okay. Coming towards next formula, that is neither A nor B, means the shaded area here. Okay, not even A and B. So outside of it. So 1 minus probability of A union B. A union B will be the shaded area in red, right? Including the intersection. So this is your A union B. So 1 minus A union B will be probability of neither A nor B. Okay. So it means probability of A complement and B complement. Okay. Which means probability of A intersection B complement. Sorry, A union B complement, which is 1 minus probability of A union B. Okay. And the last one is either A or B, but not both. Okay. So only one at a time, either A or B, only one, A or B, not the intersection of it. Okay. In that case, you have to just add only A plus only B. If you add only A and only B together, then you will get only A or only B. Only one at a time, only A or only B. I hope you are getting these situations. So this is how you will implement the formulation. You will create your own formulation whenever you come across such problems. Okay, it's nothing new. I'm just writing it in the formulas. Okay, clear till this? Okay. If it is clear, then I'll go to the next slide. Probability of A complement B. Okay, when B is already occurred. You know what is this probability of A when B is already occurred? How you will calculate this probability of A intersection B divided by probability of B, right? This is the formula we have already studied before. It was like this we have studied probability of B into probability of A when B is already occurred, right? But if you take this probability of B down in the denominator, this is how it will look like, right? So, but whenever you come across situation, whenever probability of A complement when B is already occurred, means probability of not getting uh, a black ball when a black ball is already drawn from the box. So under such situations, like you can use this formulation. So it is probability of same formula in replace A with A complement. That's all. So it's a probability of A complement intersection B divided by probability of B. Okay. And what is probability of A complement B? It's the probability of B into probability of A intersection, probability of B minus probability of A intersection B. How I have written? From equation number 1. Sorry, from equation number 2. From the previous slide. This is equation number 2. Probability of A complement B, right? It's probability of B minus probability of A intersection B. Right? And then if you break it from here, probability of B divided by probability of B is 1 minus probability of A intersection B divided by probability of B. And what is this? It is probability of A when B is already occurred. Okay. So in general, what we have proved from this is probability of A complement B, probability of A complement when B is already occurred is 1 minus probability of A when B is already occurred. I hope you are equating these two to understand. Probability of A complement when B is already occurred is equal to 1 minus probability of A when B is already occurred. Okay. Next formula. Probability of A given B complement and probability of A complement given B complement. Okay. Formulation is more or less similar. Probability of A B complement will be probability of A intersection B complement divided by B complement. We are just replacing B with a B complement. That's all. And then simplifying it. Okay. So this is what you are going to get. And here both A as well as B is replaced by A complement and B complement. And you'll get answer accordingly. Okay. Any doubt in this formulations? The reason behind explaining this is like if some wording is used in problem which belongs to one of these cases, you should be able to create your own formulation and solve that problem. Okay, it's not that difficult. Even with a simple basic knowledge of intersection and union, you will be able to solve it. Okay, as you can see, these derivations are not that difficult. Okay. Before we jump into the problems, I will explain one more theorem to you, that is Bayes theorem. And so that after that we will solve problems only. Okay. So write down heading Bayes theorem. I'll go to the next slide. I hope this new slide is visible to you all. Write down heading Bayes theorem. if E1, E2, E3, so on till En are the mutually exclusive events, okay, I'll repeat, if E1, E2, E3, so on till En are the mutually exclusive events, such that such that neither of the event have probability 0, okay. Look at this definition. If E1, E2, E3, so on till En are the mutually exclusive event, it means all events are covering your entire sample space, right? This sample space is by E1, another by E2, E3, so on. And none of the probability of the event is 0, means each event will have some probability basically, such that, okay. And let's say you are considering an A is an arbitrary event. I think it's, we should remove this here, such that, okay. So it's a given that E1 to En are the mutually exclusive events with some probability. And let A is an arbitrary event which is a subset of all these mutually exclusive events, okay. So it is subset of union of all these mutually exclusive events, E1, E2, E3, E4, E5, so on till En. Means it will have some intersection with E1, it will have some intersection with E2, it will have some intersection with E3, E4, E5, E6, so on. I hope you are following me, okay. So the total probability of A will be probability of A intersection with E1 plus probability of A intersection with E2, probability of A intersection with E3, so until probability of A intersection with En. Right? Clear? Is it clear to you? In this situation, what Bayes theorem tells, we'll see in the upcoming slide. Okay, how to find the probability of A and how to find the dependent probability, we will see in the next slide. But at least I expect, at least have you understood the um, situation here, okay, or the given data here. E1 to En are the mutually exclusive events which is covering the entire sample space, okay, and probability of all the mutually exclusive events exists, okay. It means it's not equal to 0, okay. And now we are considering an arbitrary event A which is a subset of all these events, okay. So that probability of A can be written as probability of A intersection E1 plus probability of A intersection E2 plus probability of A intersection E3, so on till probability of A intersection En. Is it clear till this? In this situation, how to find the probability of A is, let's see. As I said, probability of A is probability of E1 intersection A plus probability of, I'll go to the next slide. Probability of A will be equal to probability of E1 intersection A plus probability of E2 intersection A, so on till probability of En intersection A. You know this A intersection B formula you can apply. Probability of A intersection B is probability of A into probability of B when A is already occurred. So using that formula, I can write probability of E1 intersection A as probability of E1 into probability of A when E1 is already occurred. Similarly, for the probability of E2 intersection A, I can write probability of E2 into probability of A when E2 is already occurred, and so on till probability of En into probability of A when En is already occurred. So rather than writing this long term, I can say in general summation I is equal to 1 to n probability of EI into probability of A when EI is already occurred. So this is how you will kind of finding the total probability of unknown event A. Okay. So this is the first part of the Bayes theorem, that is how to find the probability of the unknown event A. You can also find probability of EI when A is already occurred, okay, or in other words, probability of EI when A is known to you is given by probability of EI intersection A divided by probability of A. I'll repeat, probability of EI intersection A divided by probability of A, or probability of A intersection EI divided by probability of A, right? Because A intersection B or B intersection A both are same, right? So it is a probability of A intersection EI divided by probability of A. Okay, or probability of EI intersection A divided by probability of A. What is probability of EI intersection A? Probability of EI into probability of A when EI is already occurred divided by probability of A. So like this, you can calculate probability of any mutually exclusive event when A is known to you. When probability of A is known to you. Yeah. I hope you remember what you have studied previously during your engineering. So this, I hope you are trying to correlate that. Is there any doubt? What in the Bayes theorem, is it clear to you? Let me know if you have any doubt in this. Okay, things will be clear more again when we solve some questions. Yeah. Okay. So let's solve one question on it so that this concept will be robust. Okay. Let's solve one question to make this concept robust. Okay. So we'll solve this last question and then we'll end our session. Okay, quite big question. A diagnostic test has a probability of 0.95 of giving a false positive result. Okay. When an applied person is suffering. So what is this? This is the conditional probability. Okay. Probability of getting positive result when person is a sufferer is 0.95. That is what given to you. And the probability of 0.1 given a false positive when applied to a non-sufferer. It means probability of getting a positive test or positive result when applied to a non-sufferer is 0.1. Okay, so this is what given in the first statement here. I'll repeat. A diagnostic test has performed or has a probability of 95% or 0.95 of giving a positive result when applied to a person suffering from a certain disease. Okay, so probability of getting a positive result when it is sufferer is 0.95, and the probability of 0.1 of giving a false positive when applied to a non-sufferer. It means probability of getting a positive result when person is a non-sufferer, given that it's a non-sufferer, so it's a conditional probability again, that is 10%, so it is 0.1. Okay, this is the given in the first line. Then what they are mentioning in the second line, let's see. It is estimated that 0.5% of the population are sufferer. Okay, so probability of sufferer is how much? 0.005, right? Because 0.5% of the population is sufferer. So what is probability of non-sufferer? It is 0.995, right? Indirectly they have given probability of non-sufferer also. This is the given data I'm writing, just nothing else. Okay, so this is the given in the second line. So we are done with the first line, we are done with the second line. Now we'll go to the third line. Suppose that a test is now administered to a person about whom we do not have relevant information relating to the disease, apart from the fact that he comes from the population, he or she comes from the population. It means we don't know whether that person is sufferer or non-sufferer. We just know it is coming from the population from which this data is being captured. Okay, so it's a random event. What is given in the last fourth statement or fourth line is the question: calculate the following probability that given a positive result, okay, probability uh, uh, of probability that given a positive result person is a sufferer, means the probability that person is a sufferer given a positive result. This is what they are asking to you. Okay, given a positive result means it's a known probability, right? It's a conditional probability. Basically, given a positive result person is a sufferer, this probability we have to find means it's a conditional probability, and this is your question. Is it clear what is given in this question? Do you have any doubt in this? If you have any doubt till this, feel free to ask. Then only we can solve this question. Okay, if inputs are clear to you, then only we can proceed for the solution. Okay, suppose this is your entire population or sample space. The sample space is divided into two type parts. One is sufferer and non-sufferer. And okay, and we are performing one test, a random experiment A, which means basically performing a test. Okay, diagnostic test. Okay, event A is here, diagnostic test. Okay, I hope you are getting it. So how you will calculate the let's say the event is diagnostic test giving positive result. Okay, positive diagnostic test. Okay, because it's given that given a positive result. So what is the probability of getting a positive result? Can you tell me? So this is same as the Bayes theorem which we have studied, right? We have n number of independent event. Here we have only two independent event, S and non-NS. S means sufferer and NS means non-sufferer. And we have an event A, which is a diagnostic test with a positive result, right? So what is the probability of getting a positive result? Probability of positive result, either you can get if person is positive and the test is also giving you positive result, or the person is negative but test is giving you the false positive result, right? So these are the two situations. So the person is sufferer and and you are getting a positive result when person is sufferer. Okay, or person is a non-sufferer and test is giving false positive result given the person is non-sufferer. I hope you are following this line. This is very, very important how I have written it. Okay, you are getting a positive result in two situation, when a person is sufferer and you are getting a positive result, and when a person is negative and you are getting a false positive results. So this is how you will write the probability. So probability of sufferer is 0.005. Probability of positive result when person is sufferer is 95%, so it is 0.95. Probability of non-sufferer is 0.995, and probability of getting false positive results when person is non-sufferer is like a 10%, which means 0.1, right? So this is your probability of getting a positive result. Is it clear till this? What is the answer you are getting? 0.005 into 0.95 plus 0.995 into 0.1. I think 0.10425 is what you will get. This is your probability of getting a positive result. But what they are asking in this question is calculate the probability of a person is sufferer given a positive result. So probability of S when P is already occurred, probability of S when P is already occurred is probability of S or probability of S intersection P divided by probability of P, or in other words probability of S into probability of P when S has already occurred divided by probability of P, right? So what is P of S? Probability of sufferer, that is 0.05. Probability of getting a positive result when person is sufferer is 0.95, and probability of positive result we have already calculated, that is 0.10425. Okay, so finally you will end up with 0.0456 is the final probability. Okay, is it clear till this? Okay, I hope things are clear till this. In the upcoming session next week we will solve some more questions on the Bayes theorem and other questions also randomly from addition theorem and multiplication theorem, so as to make our concept of probability more robust. Okay, so we are at the end of the session now. We'll close the session today and we'll meet again next week with some more problems and new points. Okay, do you have any doubt till this? Okay, if no doubts, then thank you all for joining this class, and let's meet again next week. Bye, have a good Sunday. Thank you all, bye.